Okay, everyone, we are now going to discuss about inverse of a square root function. So notice that here I wrote a very important note. We must get the domain and range of the given square root function in order for us to know what domain restriction we must apply on its inverse function. Why is this so? You would find out later that once we generate the inverse function, it's really going to come out as a parabola, which is a quadratic function, which you all know is supposedly not having any inverse. But with the help of the domain and range of the square root function, we will be able to know the restriction that we need to apply on it in order for it to become an inverse to this square root function. I know that's a lot to take right now, but you would know later what I mean when we start graphing. The next thing is that again, graphing on Desmos will help. So let's begin with an example. Let's go ahead and plug this in on Desmos. Okay, so this is our given function, and this is how square root of x plus 3 looks like. Our goal now is to generate the inverse to this square root function. So let's go ahead and follow some steps. All right, so let's go ahead and take a look at all these steps. First step, get the domain and range of the given function. Next is change f of x to y, followed by flip x and y. Next step, solve for y. Next step, change the y to the inverse function notation. Next, flip the domain and range of the original, and then apply the domain restriction to the new graph. Let's begin and show that. So how will that look like? Okay, so analyzing this graph, your domain are all the x values starting from -3, and your graph goes to the right side, going to the right side, positive infinity. So therefore, your domain are all the x values that are greater than or equal to -3. Okay, now let's look at the range. The range are all the y values, so when you have the graph, you're marking the bottom to the top. The top is going to positive infinity, so what's important is where it starts, which is at the bottom, which is y equals 0. So therefore, your range is y greater than or equal to 0. Greater than or equal because your graph is found above the 0 mark. All right, so now it is important for you to please take note of those. So again, the domain for this particular graph, which I sketched here, is x greater than or equal to -3, and your range is y greater than or equal to 0. Now let's go ahead and begin the process of getting the inverse. So the second step is change f of x to a y. And then now let's go to the third step, which is flip the x and the y. And then now you're going to algebraically isolate the y by raising the power of this side to a 2, and that cancels out the radical. Whatever you do on this side, you have to do on the other side. So now it cancels out, and this side will just be y plus 3 equals x squared. Now we're going to go ahead and subtract 3 on both sides, or we will do the shortcut, which is move the positive 3 to the other side, but make sure it becomes negative. Okay, notice right here that this is already a quadratic equation, which is a parabola. Therefore, we will have to do the sixth step, which is to flip the domain and range for this inverse function. What's gonna happen here, because you have actually gotten the inverse of this original function, their domain and range will also flip. We're going to use the domain for this inverse function using the range. So the range of this becomes the domain for that inverse function. But make sure that since this is the domain, make sure that the y is also changed to an x. So the domain for your inverse function is x greater than or equal to 0. And of course, your range is going to be the domain of the original function. So your range is going to be y is greater than or equal to -3. By the way, do not forget to change this back to its inverse function notation. And so now your final answer for this problem is going to be inverse function of x equals x squared minus 3 with the restriction of the domain being x greater than or equal to 0. So you might ask, why is it the domain is the only one we are restricting? Yes, that's the only one we are restricting. Every time you get an inverse function, you don't restrict the range, it's only the domain we are restricting. And then now let's go ahead and plug in the inverse that we found on here to see how the graphs look like. All right. As I said at the beginning of this video, if you do not restrict your inverse, then it looks like this parabola. And it cannot be like that. It has to look like this, like the inverse of this one. So therefore, we are going to restrict it using our identified domain, which is x greater than or equal to 0. And the moment we do that, we come up with these beautiful graphs right here that are symmetrical about the y equals x line. All right, for our next example, example number 2, f of x equals negative square root of x minus 1. Let's plug this in on Desmos. So this is how our graph looks like, and we are going to now determine our domain. The domain starts with 1 and it goes to the right. So therefore, it is x greater than or equal to 1. Greater than because it goes to the right side. Now let's look at our range. Range are all the y values and it starts with the 0 and goes down. So therefore, your range are all the y values that are less than or equal to 0. Less than or equal because it goes down. So once again, this is our domain, x greater than or equal to 1, and then our range is y less than or equal to 0. Our sketch of the graph is here. Let us begin the process of getting the inverse. So our first step is to go ahead and replace the f of x with the y. Now flip the x and the y, and then now algebraically isolate your y. So the very first thing that we can remove here is the negative 1 right in the front of this radical sign. So we will have to divide this side by a negative 1 in order to cancel that out. Whatever you do on this side, you do on the other side. All right, so the next thing that we can do is to raise this side to a power of 2 in order to remove the square root sign. And then here, whatever you do on this side, you do on this side. So also raise this to a power of 2. All right, so at this point, the only step that's left to be done is to remove the negative 1 by adding a 1 on both sides. Shortcut is take the negative 1, move it to the other side, but make sure to change the negative into a positive. All right, so this is now the inverse, and we are now going to know what restriction to do by reversing our domain in range or flipping our domain in range from our original function. The domain will be our range now, and then our range will be our domain now. Then make sure that this y is changed into its inverse function notation. Okay, so this is our partial solution to this problem. We're not done yet because we need a restriction. The x over negative 1 is just a negative x. So let's go ahead and do our domain and range. So again, our domain is the range of the original function. So this is going to be x less than or equal to 0. And then of course, our range is the domain from here, which is y is greater than or equal to 1. And so now we're going to put that restriction on here, making it become x less than or equal to 0. And let's go ahead and confirm this using Desmos. All right, so this is how our graph looks like without its restriction. And then now we are going to restrict it following our generated domain, which is less than or equal to 0. Then now your graphs are indeed inverses because they are now symmetrical about the y equals x line. Okay, let's now go ahead and do our last and final example. Let us plug this in on Desmos in order for us to easily find its domain and range. All right, so this is how our graph looks like. All right, so our domain are all the x values that are greater than or equal to negative 5, greater than or equal because the graph goes to the right side going towards infinity. Now, let us analyze our range. So again, range are all the y values, and this is your starting y value right here. It's at -2. And then your graph goes down. Therefore, your range are y less than or equal to -2. Let's write that down. All right, so let's now go and start the process of getting the inverse by changing f of x to a y. And then now flip your y and x, and then isolate your y. The first step in isolating the y is this -2 right here, or -2. We need to remove this, and the way to remove is to add 2 on both sides. Shortcut is take the -2 to the other side, but make sure to change the sign to a plus. All right, so your next step here is to remove this -1 right in the front of your radical sign. And the way to do that is to divide this by -1. Whatever you do on the right side, you do on the left side. Okay, then now you can remove the square root sign right here by squaring this side. And whatever you do on the right side, you also have to square this. So now for this side, you will just have y plus 5, and then you will have x plus 2 over -1, all in parentheses squared on that side. Then you will have to remove the positive 5 by subtracting 5 on both sides, or shortcut of taking the positive 5, moving it to the other side, but make sure it becomes negative. So this is now our inverse function. We will just have to change the y into the inverse function notation. All right, so this is our partial solution. We are not fully done. We will have to put the restriction on the side after we flip the domain and the range that we got from the original equation. All right, so for our inverse function, our domain will be the range here, which is we will change the y to an x, and it will be x less than or equal to -2. All right, so once again, the range is the domain for this one, and then the domain for this one is the range for the inverse function. All right, so this is our final answer. It is inverse function of x is x plus 2 over -1, all in parentheses squared, minus 5 with the restriction of x less than or equal to -2. Let's go ahead and confirm this using Desmos. All right, so as you can see, our graph is a parabola. It does not match the inverse of this radical function. So therefore, we will have to restrict the domain with what we got. And once we do that, we come up with this graph and we check by putting the y equals x line, and these two are symmetrical about the y equals x line. So there you go, guys. I hope that you have learned a lot today. Let me know if you have any questions.